Hey, welcome to another informative video. This video is going to be about, more specifically, what can you use the oil for in order to cool the engine a little bit better. Last time we talked about using the oil generally and how things generally work, some heat transfer type stuff, how much oil can you expect to get, how much temperature can you expect to pull off of the head using something like, let's say, a spray bar, which is listed right there, and how much heat do you expect to pull out of the system with the oil cooler. Like I said, I want to do things that are more specific, but in order to go into the specifics, I need to go back into this particular mod for just a little bit. So let's give that a shot. So here we are back at the spreadsheet that I was working with last time. If you don't recall, this spreadsheet involves a 30 millimeter pump, which is larger than stock. And I was taking 7/8 of the oil and putting 7/8 of that pump's oil onto the head because Bob Hoover said we could do it. And I showed that you can't do it. You're going to fry your bearings if you do something like that. That doesn't mean that you can't put some of the oil on the head because, well, that's a bigger than stock pump. So why don't we take the part of the oil pump that is bigger than stock and put that on the head? In other words, I'm going to go from 7/8 onto the head, 1/8 on the head. So 1/8 of the oil on the head. These numbers are now reversed. And in the prior video, I kept asking you, do you see a problem with the numbers? Is there something wrong? Yeah, there's something wrong. This TC was temperature coming out of the cooler. Remember we said the cooler is not capable of getting more than about 25 degrees worth of temperature differential. Sump to out of the cooler. And right here I'm saying I got 75 degrees. So it comes out of the cooler at 175. And I want it to go into the sump at 250. I don't want it going any higher than that. Well, it's 2.3 horsepower. Okay, first of all, we know for a fact that coming out of the cooler is not 175, it's 225. Okay, now my horsepower is way down there. The other question is, since it's coming off the head, why don't I just imagine that the temperature coming off the head is going to be a little bit higher? Why don't we give it another 25 degrees? 275, 1.6, maybe. And the reason I say maybe is as follows. There is a property that we need to talk about. I flashed it on the screen last time, didn't talk about it because basically the editing wasn't good. But it is relevant today. It is this one. It's called the heat transfer coefficient. You see this thing called A right there. You can't really do it. It's just more like a picture than it is text. But anyway, the A represents area. And this is kind of an experimental-based constant that tells you how well that particular area is used for heat transfer. And of course, there's the standard temperature differential. What we need to focus on is the area. So let's go back over to here. This is an oil cooler. It is a device that is specifically designed to use area effectively to pull heat out. 25 degrees. Okay. On this side, we have a head that is not designed specifically to put heat into the oil. It's just a flat plate. It's got penetrations in it. It's got bumps, knobs, springs. It's a nightmare. It's got a piss poor heat transfer coefficient. So you're going to throw the oil on the head, and it's going to dribble off, sit down in the bottom of the rocker box, and basically it's going to pick up the temperature of the bottom of the rocker box before going back. I have no idea what that temperature is, but it's probably around 275, and you might at that point pull off 1.6 horsepower. I don't know. Why don't we round it up a little tiny bit? Let's see if we can take it to 2 horsepower. Yay, 2 horsepower roughly. Okay, so it comes back at 285 degrees. You combine it with the oil that's coming out of the bearings, and some temperature's still around 250 because this isn't very much oil. That's where we get left off. Your choice. I mean, I would never do this to anything. It's too much, particularly, the only people I can see doing this are bus people and airplane people. And there's no way I would do this on an airplane. What if it freaking breaks? I mean, it cracks open. It's just oh my God, it's just a nightmare. Maybe on the ground, maybe if you had a bus. We think about this. That particular hole right there, don't put these holes in. Those holes point at the backside of your exhaust port, and they're putting exhaust heat into your oil. You need to focus on this area right here. And like I said, this is a general purpose, just throw oil on the head type thing. And I personally feel as though it's not worth it. But, as a quick summary for what I was talking about last time, some of these properties, I found this particular website. It's got a really good condensed introduction to various cooling concepts. Pretty tight read, it's not bad. But what's really good about it is, let's come down here just a little bit. We've got some basic properties. Always good to have properties. You know, we don't work in the realm of make-believe. We like physics, mathematics, engineering, chemistry. So just kind of summarize some of the fluid performance characteristics. There's the old thermal conductivity. I mentioned that last time. Oil is not particularly good as far as that goes. About 1/3 that of antifreeze. Specific heat, not as good as antifreeze. I think the ratio is 1.6. Fluid density, got to be able to tell how much mass is flowing through the system. Without the mass, you can't use the specific heat. Fluid density is valid. Got to know the viscosity. And I did mention the heat transfer coefficient. Yay. Good read. Recommended. What I want to do this week now then is focus on things that I know for a fact can work or that theoretically can work. And there's something that we need to do, which is instead of thinking about general purpose cooling, we need to think about specific component cooling. And that's, in essence, what we're trying to do is spot cool. We're not trying to cool the whole head. We just want to cool some piece of the head. So in order to cool some piece of the head, we need to have some idea of what the hottest pieces of the head are, and are or are they not relevant to trying to make our engines run right. So let's take a look at that real quick. All right, so we want to do some spot cooling. So to think about doing spot cooling, we need to know what spots are hottest. So why don't we consult the guru of gurus? I can't do one of these videos without bashing Bob Hoover, so let's get this out of the way real fast. What does Bob say? The cylinder head is the second hottest part of your engine. The exhaust valves and stacks are first. Okay, let's look at that real quick. All right, exhaust valve, which is definitely not part of the head. It's not part of the stack. It's an independent thing, can be pulled off the head. A stack, which is piece of the head, but let's just think of it as something that could be pulled off the head as its own item. So I've got 1, 2 things. And wow, what's left then becomes a cylinder head, which means the cylinder head, which he's saying is the second hottest part, can't possibly be the second hottest part because he's already got 2 pieces as 1 and 2. But I've said this in many of my videos. When you're looking for information like this, you do not go to the white-haired little fart with a shop at the end of the road, because it's either Bob Hoover or somebody who has read Bob Hoover and is simply quoting Bob Hoover. And Bob in this particular case is wrong, because we're going to go somewhere where we can get some really good information. A place that is not a Volkswagen place. What we're going to do is visit an MIT master's class for mechanical engineering. What we have over here is internal combustion engines. This happens to be a 2.61 course. 2 is mechanical engineering. The .61, the .6 means it's a graduate level course. This is not for undergrads. This is not for mechanics. This is for people who are way past my friggin' level of understanding. Fortunately, what we have for this particular course are a few general outline, kind of like introduction. This week we're going to be talking about the following things. So here are some high-level concepts. What we need to look at are the high-level concepts. So we come over here to the meeting notes. Yay! And what we have is heat transfer, environment, and in here this guy, a professor, and this is relatively recent. I believe this is a 2016 class, I think. Anyway, down here, hottest components. Number 1, the spark plug. Just in case you doubt it, let's go to a spark plug manufacturer. Let's read it off right here in the middle, in blue, but I'm going to highlight these things right here. 932 Fahrenheit to 1472 Fahrenheit. Yes, absolutely, the spark plug is the hottest thing. The exhaust valve comes next, which means the exhaust valve beats the stack. It is number 1 as far as things that are, genuinely we're concerned with. Yeah, the spark plug, yeah, but it's right there. It's where the spark happens anyway, so let's not be horribly concerned with it. The exhaust valve is number 1. And now, oh my God, I've said this in some of my other videos, all the Volkswagen people ever think about is the head. Cool the head, blow air over the head, blow oil on the head, and nobody ever pays attention to the piston crown, second behind the exhaust valve, and then comes the head. So if we're going to focus on spot cooling, what we're going to do is focus on the exhaust valve and the piston crown. not general purpose cooling. Let's get serious. Exhaust valve and piston crown. Let's move on. So we're going to be doing some spot cooling, and the first thing we want to do is try to cool the exhaust valve, and we're going to try and cool the exhaust valve with some oil. So what do we do? Well, in this particular case, we're going to look at what Subaru has done. This happens to be an older rocker arm assembly from, I don't know, the 1980s, 70s, 1980s. Look very carefully right there, right here, right there, and right there. What you'll have are little ports that squirt oil. Now, the purpose with a Subaru is to squirt the oil not at the exhaust valve guide and the support for the valve guide, but they have an interference fit spring system, so that as the springs bounce next to each other, they have a tendency to dampen out vibration, helps on a whole bunch of different things. It's not for strength, it's for vibration dampening. But because it has an interference fit, you're not trying to lubricate it, you're trying to cool it. The interference fit creates heat. So they're trying to throw the oil at their dual spring system to keep the springs cool. It's a water-cooled head, you don't really need to play around with the exhaust valves and the guides. But that particular technique right there, I've never seen applied to a Volkswagen engine. Because generally speaking, the Volkswagen people aren't capable of thinking for themselves. They just go and look at what Bob did. Bob didn't think about it very much and didn't understand very much as far as I could tell. So this was never implemented. However, because nobody else has ever done it with a Volkswagen, you are on your own. You don't want to put the ports like this one right here. This, of course, would be the intake. You don't want to do that. No poking oil at the intake, because it's going to just get sucked down into your guide and you're going to burn the oil. Intake guide doesn't need to be cooled. It's only for the exhaust. How you get that aligned, that's up to you. For a car, I wouldn't do it on a car, maybe on a bus. You airplane guys, perhaps. Spot cooling, does it work? In theory, you might be able to pull a little bit of heat out. But keep in mind, we did talk about the heat transfer coefficient. And you're squirting the oil in there. And that interface, if you look at the head, it's not a great interface. There's a little bit of the guide that sticks out, and then there's the pedestal that sits around the guide, and then the spring. And you've got to get that oil, as you're squirting it out, you've got to get it through the valve spring and onto that. And once you get it there, that particular interface, it doesn't have a lot of surface area. So will it take heat out? Sure. Is it going to take a lot out? I have no idea. But in theory, yeah, you can pull a little bit of heat out from your exhaust valve and the exhaust guide and maybe get a little bit extra durability. Maybe. Let's move on to the next one. Well, next up on the list of cooling items then, since we took a look at the exhaust valve, will be the piston. So what you do is you put a notch right there. Okay? You put one notch. Not two notches, not three notches, and you do not put notches out the back side. You're like, oh, we've got a piston on the other side, I'll notch the back. No. One notch this side. Okay, these happen to be, once again, Subaru components. It is not an afterthought. Those little holes right there are in the casting. So they are cast like this. Subaru is not the only manufacturer that has done this. It's not even a recent modification. This particular modification in my reading, if I remember correctly, there were motors as far back as the 1930s that had this particular modification done to them. So it is an old and well-known modification for cooling the piston. Now, why in the world Volkswagen didn't incorporate it in the Type 1, I have no idea, but they did, in fact, put it into the Type 4 as a bulletin, a maintenance and repair bulletin, technical bulletin. You can read it on your own. It is available at Ratwell. I will let you do it yourself. But anyway, it tells you what to do and whatnot and how to do it. Just take a file and take out a little bit of metal, 1.5 mm deep in a V. Doesn't really matter that much. You can see based on this, it's just a rough casting. You're just trying to open it up and get it out there. And I did do a little tiny bit of reading where one of the Samba posters said that he had experimented with different numbers of these things, and he said that once he got to 3, it began to burn a little bit more oil than stock. So who knows? It's like an anecdote. Maybe, maybe not. That looks like a pretty good sized hole right there. It's a flat 4. You be the judge. I don't have this particular mod in mind. I figure I'll put it in the next one because I want to run my compression up. And I think by cooling my piston, I could probably have a bit more compression. Anyway, so you've got a whole bunch of manufacturers that have done this, and it was done on the Type 4 as a remanufacturing, rebuild bulletin. Now, I want to investigate this guy a little tiny bit more because, with my channel, it's not just about telling you, here's something that you can do. I like to analyze these things a little tiny bit more. And to do that, we need to venture into, believe it or not the Samba, but some comments on one of my own videos. Let's do that next. So, in order to do a little bit of thought process about the cooling potential of throwing oil at the back of the piston, we need data. This is the kind of thing that it's kind of obscure, and getting good data is really difficult. But believe it or not, I got some data from one of the more prominent and voluminous posters over at the Samba, who at some point in time, I'm not sure why he came to my channel. Anyway, he came on over and made a couple of comments about this. So we had a nice discussion going on probably about a year and 4 months ago. Anyway, well, the guy happens to be Alstrup, if you know Alstrup from the Samba. So he's got some comments down here. But anyway, Alstrup, if you're watching, I had to go back to class. I didn't stop the conversation because I wanted to. I stopped because I had stuff to do. Anyway, he's got some good comments down here. Let's take a look at the first piece, which is down here. If you, on the other hand, climb, say, a 4% incline at 65, you will notice that the oil temperatures will soon increase to something like 6 to 10 degrees Fahrenheit over what the conventional engine will show. And we have to include the next part as well. Well, the conventional engine will get there, but it will take significantly longer. He's right. I've never said that, like, you throw a little bit of oil around, it doesn't mean that you can't use it, but the cooling is dominated by the air and the metal. So it goes into the metal first, and eventually the oil kind of catches up. What the hoover mod does apparently, is bring us up to wherever it is going to eventually get to anyway, but it gets to that point sooner. But once you've hit equilibrium, you're still at equilibrium, hoover modded or not. That's what he's basically telling us. But there's something else about this particular thing. This particular anecdote right here is not full. And when he mentioned this, because I go and I read it to Samba, I knew exactly what he was talking about. And he's actually got, as the source for this particular thing, he's got an engine and a vehicle that they did this test in. It's a bus. And so anyway, the information is over at the Samba in one of those postings. I'm not going to do it, but it's over at the Samba where he talked about this a little tiny bit more. And the bus, from what he's saying, there are a few modifications that are going to swing things this way and that, but the bus was hoover modded. And that's what he's saying, is that the difference between this and that is a hoover modded. That 6 to 10 was hoover modded. All right, one more little piece. By the way, a VW Type 4 block actually has most of the hoover mods built in if you look carefully. The missing parts were added in a supplemental information package in 74, 75, I forget it, but for some reason never implemented at factory. I just showed you what that bulletin was, and it's about the piston. But since I'm probably the world's foremost authority on Bob Hoover's writings, I can guarantee you that that particular bulletin is not a hoover mod. See, Bob didn't understand physics. And to understand why that thing works, you have to understand physics. So Bob would never have been able to understand how it works. He never would have come up with it himself. Therefore, it is not a hoover mod. In addition to that, swivel feet, which is one of his grand and glorious miracle pieces, does not have a Volkswagen part number. Slicing open the lifters in order to have 100% oil flow to the heads, never part of a Type 4. Solid lifters, never had a double band, no slicing, no 100%. Absolutely not. There is no secondary oil passage back and forth from one side of the block to the other. It does not exist. It is not hoover modded. There's only one of those mods that's on the Type 4, and it is the little band that goes around the rocker shaft. So no, yeah, you get different opinions, but no, I have done more than enough work with that hoover mod to know that no, the Type 4 was not hoover modded. All right, let's go back to what we have up here with the bus, because believe it or not, that anecdote is from the bus. Let me find it. And I know that that particular bus has not only the hoover mods, but it also has the rod notch mod. And that 6 to 10 Fahrenheit over the conventional engine, where does it come from? When you've added something on top of what should be just the hoover mod, You have to sit there and figure out, well, where did the temperature differential come from? How much came from hoover modding and how much came from the factory mod? Well, you know for a fact that this puking oil on the head by slicing open the lifter was never done on the Type 4s, never done on the Type 1. Remember, they produced Type 1s in Mexico until 2002. Never part of what they did. So this 6 to 10 degrees Fahrenheit, we can come to one conclusion, that 6 to 10 degrees Fahrenheit did not come from the hoover mod, but it came from the rod notch mod. The hoover mod is a turd. I stand by that. Sorry, Alstrip, it's a turd. The data. What can we do with the data? Well, we've got a 6 to 10 degree number. Okay, let's give the hoover mod credit for like, I don't know, a degree or two. So instead of 6 to 10, let's call it like 5 to 9. And let's just average it out and say it's 7 degrees, roughly. Okay, based on what I talked about on the prior video, if you throw all that oil on the head, the best we the best we could possibly come up with was about a 20 degree change. And that the 20 degree change equated to about a 1 horsepower increase in the power requirement dissipated through the cooler. So we go back to the bulletin that Volkswagen gave us about piston cooling with that little rod notch, and that bulletin will not say anything about how you need to stick a great big oil cooler on the system now that you've performed this modification. So once again, we've come up with a modification that is not capable of pulling significant amounts of heat off of what you need to be pulling off in order to dissipate the waste heat. It's just, like I said, it's a spot cooling component. But what can we do with it? You know, maybe we can come up with some kind of a guess as to how much additional horsepower we are pulling off. So let's take a look at it. Anyway, that modification uses oil that has gone through the bearings. Therefore, the bearings are the source temperature. So this 225 is no longer 225. It's, let's call it 250. Sump temperature, 250. All right, that's 0 horsepower. So what is the temperature coming off? Pistons are pretty darn hot. We don't want it going up too terribly hot, right? But we do want to pull some heat off. So what do you say, 350? I know that the backs of some of the pistons that I've looked at, when I pull an engine apart, you will get a certain amount of coking and stuff on the back of the piston. So you know it gets pretty darn hot back there. So let's call it 350 and see what happens. All right, 3.28 horsepower. But there's a problem. I was referring to 1/8 of the entire output of the pump going onto the head, but this is waste oil. We don't know how much is actually going in there. How about half of that? It drops. I don't think it's even a half. How about a quarter of that? That gets us down to there. Again, it's not very much. And keep in mind that the stock system is also putting oil onto the piston, and that there is a baseline from which you are now trying to increase. Who knows what the baseline is? For all you know, the baseline could be half a horsepower, and that we're actually only making 1/3 of a horsepower difference, which is not going to impact the system greatly. It'll just simply cool our piston and give us a slightly cooler bottom of the combustion chamber. Well, after running through all these numbers, bottom line is, are we going to need a bigger oil cooler? Have we made such a huge difference with our spot cooling that we now need a bigger oil cooler? Absolutely not. Okay, we know from the last video that a 20 degree temperature differential caused by directly shooting the oil out of the spray bar onto the head isn't going to make that big a difference. Not so much that you need a bigger oil cooler. And of course, these are spot cooling things, so they're not going to need a bigger oil cooler. It's not just because I'm telling you that they don't need it. The bulletin for the Type 4, if you needed a bigger oil cooler, they would have had to have addressed the issue of the elevated oil temperatures, and there was no need to address it. They didn't address it, therefore it doesn't exist. The stock cooler is more than adequate to deal with spot cooling. There you go. So that kind of summarizes it. Spray bars, might be a little bit effective if you're bleeding edge and you really want it. Spot cooling after that. The rest of it, no. And I do need to bring up and mention, once again, airplane. All right, I know a bunch of people watch these videos are airplane guys. RevMaster is the king. Not Bob Hoover. RevMaster. You go and you look at what RevMaster does with their engines. They got a 2.3, the RevMaster 2300. No swivel feet. Not Hoover modded. No spray bars. Doesn't even have the rod notch modification. Got a gigantic oil pump, but it also has a gigantic bearing right back at the prop. So they've got to feed oil into that gigantic bearing, so they gave their engine a gigantic oil pump. It's there for that gigantic bearing. And if you look at the oil cooler that those guys use, oh, whoopie freaking do, it's a 5 horsepower cooler. So yeah, the masters of sustained high horsepower output do not do anything with the oil other than pretty much stock and then feeding their gigantic oil cooled and driven bearing. Revmaster, go check it out. I mean, maybe I'll put a link down in the descriptions. I don't think that I want to do anything else with this. It's getting kind of long. There's really not much left to do other than to continually bash things like Bird, Hoover, Raby. Don't want to bash Allstrip. Allstrip tries to do things and learn. But yeah, he's just off base with this one. Trying to puke oil on this stuff, it just isn't going to make a huge difference. Anyway, I've got more stuff coming. Thanks for watching. More later.